And now, ladies and gentlemen, we're proud to present the grand prize winners in this year's competition. Those components that have most successfully met the criteria for excellence of design in a powder metallurgy component. In the automotive transmission category, Stackpole Automotive Gear Division and its customer, Magna Powertrain New Process Gear Division, have received the grand prize for a high-precision PM steel clutch hub. Stackpole selected a special low-cost lean alloy material to meet strict dimensional control, compressibility, and durability requirements in a demanding performance environment. The complex 6-level part operates in the clutching system of an active 4-wheel transfer case in light trucks and SUVs. The clutching system replaces a manual synchronizer system, allowing full-time active control of torque transfer. It allows variable torque distribution to the vehicle's front wheels on the fly. High-temperature sintering, 2,336 degrees Fahrenheit, provides impressive properties. A minimum density of 7.0 grams per cubic centimeter, 165,000 psi tensile strength, yield strength of 150,000 psi, and an apparent hardness of 35 HRC. The complex castellated geometry required innovative tooling to precisely control lengths, diameters, densities, weight, and runout, as well as an even density distribution throughout the part. The tool set has 3 tools acting as dies. Annual production exceeds 600,000 parts. FMS Corporation and its customer Team Industries have earned the grand prize in the competition's Lawn and Garden Off-Highway category for an assembly of 6 net-shaped precision PM parts that make up the forward-reverse actuator assembly in off-highway vehicle transmissions. By changing the electrical switch, the assembly actuates the transmission linkage to engage either forward or reverse gearing. The parts are made to a typical density range of 6.6 to 6.8 grams per cubic centimeter. Most of the parts require heat-treated properties of 120,000 psi tensile strength, 110,000 psi minimum yield strength, 43,000 psi fatigue strength, and a typical hardness of 35 HRC. While no machining is performed on the parts, secondary operations include zinc plating and vacuum oil impregnation. Team Industries estimates that PM delivered a 50% cost savings over the next most competitive fabrication process. In the hardware appliances category, Metal Powder Products Anaheim has won the grand prize for a 316L stainless steel secure cap cover that is used with 2 other PM parts in a fire protection locking system. The complex part features large external tabs that are precisely oriented to an internal depressed waveform that allows it to mesh with the other PM parts. Made to a density of 6.5 grams per cubic centimeter, the cap cover has a 20,000 psi yield strength, a 55 HRB hardness, and an as-sintered elongation exceeding 20%. The customer subjects the part to a rigorous impact and abuse test to prove its integrity against vandals. The 3 external lugs must withstand the impact of a 10-pound sledgehammer and a torque loading of more than 500 pounds. The main body is also resistant to drilling. The customer realized cost savings of more than 80% by choosing PM over conventional machining. The grand prize in the hand tools recreation category goes to Megamet Solid Metals Incorporated for a trigger guard made by Metal Injection Molding for modern muzzle-loading incorporated night rifles. The MIM guard supports the trigger group and hammer in the quick detachable trigger mechanism in a .50 caliber muzzle-loading hunting rifle. Made to a density of 7.4 grams per cubic centimeter, the 3.1-ounce MIM steel part has an as-sintered tensile strength of 94,250 psi and a 58,000 psi yield strength. The part is held to critical dimensions of plus or minus 0.005 inches. Megamet performs these secondary operations: reaming 3 holes, tapping 2 screw holes, and deburring. The customer applies the black oxide surface finish and drills 1 hole because of a design change. Choosing the MIM process provided substantial cost savings. Flowmet LLC and its customer Ormco Sibron Dental Specialties have won the grand prize in the medical dental category for 3 parts: bracket, slide, and removable drop-in hook used in the Damon 3MX self-ligation orthodontic tooth positioning system. 1 bracket and 1 slide go on each tooth, with the hook optionally for about 5% of the teeth. The very tiny, intricate parts are made by metal injection molding from 17.4 pH stainless steel powder to a density of 7.5 grams per cubic centimeter. They have impressive physical properties: a tensile strength of 172,000 psi and a yield strength of 158,000 psi. All of the parts are made to a net shape. The customer tumble polishes them and performs a brazing operation before assembly. Lovejoy Sintered Solutions LLC and its customer Petrotech India Portugal have won the grand prize in the Industrial Motors, Controls and Hydraulics category for a complicated 5-level rotor. The rotor functions as part of an assembly in hydraulic pumps that draw up petroleum fuels from an in-ground tank to the above-ground nozzle. The part has 9 legs, each 50 millimeters long and 10 millimeters wide, creating a 5:1 aspect ratio. The legs are pressed to a density of 7.1 grams per cubic centimeter and the hub area just over this density. Made from MPIF F0005-25 PM material, the rotor has a tensile strength of 33,000 psi, a yield strength of 27,550 psi, and a 56 HRB hardness. Lovejoy performs some machining on the hub and cup. The customer estimates they realize a 30% cost savings versus the machined casting used previously. This dipole cryomagnet end cover, fabricated by Bodycoat Hip Sorahammer in Sweden for Metso Materials Technology Oy, Finland, for delivery to the Particle Physics Center of CERN, the European Organization for Nuclear Research, has won the grand prize in the other market segments category. The world's largest scientific laboratory, CERN covers 6 square kilometers, scattered over 12 sites on either side of the Franco-Swiss border near Geneva. The end cover is used in the Large Hadron Collider, the world's largest and highest energy subatomic particle accelerator, which consists of over 34 kilometers of tunnels and caverns built more than 100 meters underground that will enable scientists to study and understand the structure of matter and the forces that hold it together. Made from 316 LN stainless steel powder, the part is hot isostatically pressed to full density. The superconducting dipole cryomagnets operate in a cryogenic environment at minus 450 degrees Fahrenheit. As hip to a near-net shape weighing 253.5 pounds, the finished end cover weighs 153.3 pounds. Bodycoat incorporated finite element analysis, computer-aided design, numerically controlled sheet metal cutting technology, and cutting-edge robotic welding and part manipulation to produce the end covers. This resulted in a more than 50 times increase over the typical production rate of fully dense-hipped PM near-net shapes. an unprecedented breakthrough in hipping productivity. About 2,700 end covers have been delivered to CERN. The design of the part features several complex configurations. For example, both the inner and outer surface of the broad face is radiused with the inner surface approximately parallel to the outer surface. The exterior of the curved surface has either 8 or 10 projections, depending upon which version of the part is produced. The design differs slightly depending on which side of the dipole magnet it is located. The PM hipped part meets the equivalent mechanical properties of 316 LN wrought stainless steel, including internal toughness and high ductility. There you have them, ladies and gentlemen, the grand prize winners in the 2007 PM Design Excellence Awards competition. Please join with us in welcoming them to the stage as we invite them to receive their awards.